Okay, welcome to CS 161, Discussion 7. This is the walkthrough for web security. So we're going to start out with a quick intro to web, and specifically websites. So what are the big components used to design websites? Well, we start with HTML, and HTML is the code used to format the page. So whether you have header elements or paragraph elements, these are all contained within these HTML tags. So this h1, and then we have some string, and then a close tag for h1. This is one HTML component. CSS is the code used to style the page. So in this particular case, we are taking the h1 element and we're assigning a style to it. This isn't really relevant to security, but it is something that you might see. We finally have JavaScript, which is the code that's used to manipulate the page. So JavaScript can do a lot of different things, but here's a simple example. So you can see it's surrounded by these script tags, and we're passing in this function call to the alert function. And what this will do is it'll show a pop-up that says 1. So super simple, and we can embed these throughout the page. So that's a quick intro. Let's go into a little more detail. What can HTML do? Or I guess what can you do with HTML? Well, the first is, just simple create links. So you can set like a hyperlink. So this click me is a hyperlink, and the URL that's behind it is this google.com. Now, this is a super common way of doing some phishing attacks where you simply trick somebody into clicking a link that is actually going to, potentially going to a malicious place here. You can also query and embed images. So in this case, we can have something like cs161.org/picture.png, and this will take us to, this will query the image loaded at this address and pull it into this image tag. And similarly, if we pass in, some other URL that doesn't actually go to an image, it will still make a GET request to that URL, but it won't actually render that image locally. So this image tag will always try to look for a URL, make a GET request to that URL, try to pull an image down. If it can pull that image down, it'll render it. If it fails to find an image, it'll still make that GET request, but nothing will really happen. We can also embed JavaScript. So like I said earlier, this is a super simple example. And we can embed other web pages. So we can use these things called iframes to embed websites inside of other websites. And a quick note about iframes. Browsers enforce this thing called frame isolation. So the outer page cannot change the content of the inner page, and the inner page cannot change the content of the outer page. So that's HTML. Let's talk about JavaScript. So JavaScript can do a lot of things. So you can change page content. You can hide or unhide the cursor, so the arrow. You can access or change or delete cookies. And we'll talk a lot more about cookies later on. And the one thing you can't do is access files on your computer, except where it's narrowly defined. So typically speaking, because the point here is that JavaScript is sandboxed in the browser, and there are very, very protected use cases where you might be required to actually access resources on your computer. So maybe that's through the update or upload file functionality, if you've seen that around on websites. That's a very protected API that allows us to actually do this, but JavaScript by itself, just running natively in the browser, won't be able to actually read anything, any files from your computer. This is just a protection. So that's JavaScript. HTTP is a super common protocol for client-server communication. So every time you load a website, a GET or POST request or some other type of HTTP request is made by the client, which is your browser, and the server sends back an HTTP response. So what does this look like? Well, let's take a look at this example where we are loading our emails. So we open up Gmail in our browser, and we call that the client, and then a GET request is made to the Google web server. And that web server will say, hey, I need to load this person's emails. So maybe we pass some data along with this GET request and say, oh, like I'm user Alice, and here is my unique ID. That data gets passed along to the web server. The web server will interpret this, and perhaps it goes and makes a lookup to a SQL table somewhere. Maybe it does some other processing with other servers, but at some point the web server will return a response to that original request that contains your list of emails. A post request might be something in the context of maybe you want to send an email. So the browser will send the content and the recipient of this email in a post request to the web server. And maybe in this case it is just writing to a SQL table, and maybe there's no reads performed. And when we get back a response, maybe it's a success or failure or something like that. Now, a quick note about convention. So GET and POST requests are convention. They're not forcefully enforced. Typically, the convention is to use GET requests when you're not really modifying any data on the back end, and POST requests when the intent is to write some data or modify some data on the back end. But these are convention. You might see it used in other ways at some point. So that's HTTP. Now let's talk about cross-site scripting, which is our first type of web attack. So XSS attacks. Let's think about this scenario. Say we created a Twitter account and we want to get a bunch of followers. So we want everybody who sees our tweet to immediately follow us without them actually having to do anything. So what if we make a tweet that looks like this? So we go into Twitter, we paste this into the text box when we're creating a tweet, and then we hit post. Everybody who sees this tweet at that point will essentially run the script, or I guess this script will run as soon as that tweet loads in their feed. And so what does the script actually do? Well, it is fetch, which is an HTTP GET request, like we saw earlier. And this is in JavaScript, just for some context here. So it's going to make a GET request to https://twitter.com/follow $user equals Mallory. So it is saying, create this action that triggers the follow command. So basically, every single person who clicks on this link, directly clicks on this link, will follow Mallory. But when we put this into a GET request, when we wrap this around in a GET request, this will essentially say every single person who loads this script will immediately follow user Mallory. Now, in order to load the script, the user doesn't actually need to do anything. This script, when it shows up, when that tweet loads, this script will immediately be executed. So there's no actual actions that need to happen. What we've done is we've essentially tricked the browser into thinking that there's some script that's embedded there, some actual script that's supposed to do something useful. But in this case, we're the ones, as the attacker, providing the script that's being run on all of these client devices. And so this, in summary, is an XSS attack. In particular, this is a stored XSS attack. So we are executing JavaScript on other users' devices by storing this JavaScript in a post, and when other people load that post, this JavaScript gets executed. So you can imagine that there's a number of different things you can do with this. This is a really simple example, but if an XSS attack exists, you can do arbitrary actions. You can do GET requests, POST requests. You can delete, modify cookies. You can steal different values from the page. There's many different things that could open up if you have an XSS vulnerability. So there's two different types of XSS. There's stored XSS, which is what we just talked about, where you have a post or a tweet or something like that, and an attacker just leaves that on the page, hoping that somebody's gonna scroll by it at some point. You also have reflected XSS, which is where the attacker constructs a link and gets a user to click on it. So this is a really common example of a search page where you search for something and then it says search results for, and then whatever you search for. So if you search for animals, it'll say search results for animals. In this case, what we do is we pass in a script to the actual query. And so when it says search results for, that value that actually gets displayed will be, this script will replace whatever value gets displayed. So instead of displaying a value, this script will run on that page. And so a reflected XSS attack is where we construct this link, we pass in our XSS, and that gets rendered when the user clicks on this link. With that, let's move on to command injection, which is our second big type of web attack. And so what command injection is it's essentially this way of injecting malicious inputs so that the backend does things that we want it to do. So it's a little bit like buffer overflows, except it's a lot higher level. So let's actually take a look at a specific example here. So in this case, we're using a SQL injection attack. So the particular scheme for this case is we have some sort of a browser that's making a GET request to some sort of a login page, and maybe the login is taking a username and a password here. And so this username and password could be coming from an input field. So maybe you have like some web page, maybe it has a username field and a password field, and when you click on the sign in button, this makes a POST request, or a GET request actually in this case. And it attaches the username and password to that request. Now, when the server receives this request, what happens is it does a lookup. It says, hey, I want to figure out what user is trying to sign in. So it says, select username from users where username is equal to %s and password is equal to %s. And these %s's, in this case, are the wildcards. So the username goes right here, and the password goes right here. And so this GET request will happen, this data will go over to the server, this is the browser, and the server will try executing this SQL command. And if it gets more than one thing back, or if it gets at least one thing back, it's just trying to find a match, right? Where the username is equal to something, the password is equal to something. So if it finds a match, it will grab the first thing and send that back to the browser. And it will say, here's the user that you signed in as. And so what our goal is here is to construct an input such that we can essentially sign in as any user without actually knowing a username and password. And so let's consider what happens when we pass in a username that looks like this. So if we pass in a username that looks like this entire phrase will essentially get inserted into this %s right here, this first %s. And so when you do that, the query that you end up with looks like this down here. We have select username from users where username is equal to, and then we grab this value, so username is equal to garbage, and then we have a quote, or 1 is equal to 1. And then we have a semicolon, and then we have this dash dash. And so it's a little bit easier to start with the dash dash. So this dash dash, what it does is it says ignore the rest of this line. So in reality, this line still contains all of this here. Like that, stuff, that component of this query still exists, but it will be ignored because we have this dash dash. It's a comment that says comment out the rest of the line. So we don't really care about any of this anymore. What we're focusing on is this first part right here, this part that we've injected upon. So what's going to happen? Well, it's going to select the username from the users table where the username is equal to garbage or 1 is equal to 1. So now if we take a look at this where clause, we can notice that it's always going to be true because 1 is always equal to 1 and this is an or. So this where clause effectively goes away because it's always true. Now what that leaves us with is select username from users. And select username from users will select every single username that is in the users table. And so what we'll end up with is every single user that's in the users table will be returned, whereas in our original query, we're only returning the user that had a match with the username and password. And so by doing this, we've effectively signed in as some user because we've grabbed a random username, or we've grabbed, I guess, the first username in the users table, and we're treating that as, who we're logging in as. And so we've changed the actual SQL query that runs in the backend to something that allows us to sign in. And you can imagine that this is a super simple example, but in reality, there are many more interesting things that you can do if you have an injection attack. So you can insert data into a SQL table, you can delete the table, you can modify, different parts of it. There's many different things you can do if you can inject SQL into a vulnerable text input field. So that's sort of a walkthrough of a particular SQL injection attack. Now let's take a look at the actual discussion worksheet next. Okay, so let's take a look at this first question. So what do we have going on here? So we have some website called Not Amazon, and whenever Alice adds an item to her cart from this website, a post request containing the field item is made. And when receiving a request, Not Amazon executes this SQL statement here. So let's take a look at what this actually does. We have, some browser, and when a request is made, it contains an item and also a session token. And so both of these values are effectively viewable by the user and controllable by the user. So the session token is something that's implicitly passed as a cookie. I guess that's a little bit out of scope for this particular question, but the session token is passed along as a cookie, and the item itself is coming from whatever Alice decides to buy. And so these values get passed along in this post request to the server. And what the server does is it makes this SQL query containing these two fields. So let's take a look at the actual query. Insert into cart, session items, and then it passes in the values here. So the session token gets passed into here, and the item gets passed into here. And then we execute that. So Alice is in desperate need of some toilet paper, but the website blocks her from adding more than 72 rolls to her cart. Describe the post request that she can make to cause the cart add statement to add 100 rolls of toilet paper to her cart. So our goal here is to get this statement to add 100 rolls of toilet paper. So when we're talking about SQL injection attacks, the first thing that we want to do is think about what values we have control over. So as we talked about earlier, anything in the post request we can effectively view and modify. And so this item we can modify, and this session token we can modify. And so we actually, as the user, have control over both of these values here, which means that we have control over these fields here. So at a high level, that's the first thing we've done. We've said, okay, we have control over this field right here. Is this protected in any way? Well, it doesn't seem like it, because this is just using a %s, and as we know from before, %s's are usually vulnerable. And so what we can do is we can inject into this field right here some data that will essentially cause 100 rolls of toilet paper to be added. And so when we actually take a look at the SQL syntax for this, it is effectively copying this tuple value and just pasting it 100 times into this exact query. And so we'll just keep adding values until we get to 100 rolls of toilet paper. That is the high-level thought process, effectively. So when we take a look at what this looks like, we have something like toilet paper. And for the purposes of simplicity, I'm going to say that the session token value is A, B, C, D. In reality, this would be some sort of variable that you could look up using your Chrome inspector, and we'll take a look at how to do that in future projects. But for now, let's just say that it's A, B, C, D. We have toilet paper, and that ends the first tuple, effectively. And remember, this is the field that we're injecting into here, this item field. So let me clean that up a little bit and then make this very clear. Okay, so we're injecting into that item field. So we start with toilet paper to end the first tuple. We put a quote, parentheses, comma. Then we just do this over and over again. So there's our session token. We want to add more toilet paper. And we can keep doing this all the way up to the last thing that we add. So we have maybe one more of these things. And then we can effectively terminate this with a semicolon and then a dash dash to ignore the rest of the line. Now, a couple of things here looking at this solution. What we've done is we've used this tuple and injected many, many different values that are comma separated. So that's sort of a SQL thing to just, I guess, remember. And another thing that's important to note is that we've ended this statement with a dash dash. And I apologize if that was a little bit unclear here. But we want to end this statement with a dash dash so that everything after this injection, everything after our injected input gets ignored. And so in this particular case, what that accounts to is the end quote here and this closing parentheses here. So these two things in green will be ignored because they fall after the input here. So in reality, we have something like an end quote and closing parentheses, but those effectively get ignored, which is good. Otherwise, that would probably cause some sort of a syntax error. And the third thing to note is that we can effectively perform the same injection on the session token itself, and that will look pretty similar to how this attack is structured. So that is this first simple SQL injection attack where we've we found the field that's vulnerable, which is this, this item field, and we've said, okay, what input do we craft so that we can modify what this statement actually does? And in this case, we're just adding a lot of toilet paper. All right, so now let's take a look at the second part. When a user visits their cart, not Amazon populates the web page with links to the items. And this SQL command, or I guess the sequence of SQL commands gets executed. So I'm going to pull out some important parts here. The first is that not Amazon fixes the vulnerability by parameterizing the cart add statement. So one thing that we can tell right away is that this vulnerability up here that we exploited earlier, this cart add vulnerability, is fixed. So we can't really use that anymore for SQL injection. Now, another thing to note is that not Amazon checks that session token is valid before executing any queries involved with it. And so if we take a look at these remaining two queries that we have access to, there's potentially this one and potentially this one down here. And so let's take a look at this first query. We're doing some sort of select statement, and we're passing in %s for the session. And the value that gets passed in is the session token itself. So because we have this check here, this first statement right here is fixed as well, or protected. Now that leaves us with the second statement. We have a select from items where item is equal to %s, and the item, or I guess the value of the placeholder, is this item field. Now remember, we still have control over this item field, and there's no validation being done on it, so it seems like this is the place that we want to attack. And what is the goal? Well, in this case, the goal is to still add 100 rolls of toilet paper to the cart, so pretty similar to the last part, but the structure is a little bit different since now we're injecting on this instead of what we were doing above. So let's actually take a look at this command here and see how we can use it to achieve the same goal that we had above. So the first thing to notice is that this is a select command. So when we were inserting toilet paper above, we were using an insert into command. So one thing that we have to note is that we can't really piggyback off of this command itself. We'll have to somehow use a semicolon and then execute some new command, potentially an insert into command. Because our goal is still the same, we want to insert into the cart. And so because we want to insert into the cart, we know that that is the cart, and we can sort of steal some of the syntax from above. So we have insert into cart, session, item, and then values, and we can do the session token and toilet paper, And we just keep doing that over and over again until we get to the end, and in a similar format that we did above, we end it like this. So now we've sort of taken a look at, we've understood that, hey, we need to do an insert into. The way that we do that is we use a semicolon so that a new statement gets executed, because we can't piggyback off of this select. And the final thing to do is to make sure that the syntax for the beginning and the end of this command are correct. So let's take a look at the end really quickly. This entire input is going to be fed into this %s here. So the last thing that we want to do is use that semicolon to effectively end whatever last tuple we had, and then break the rest of the line with the dash dash. So ignore the rest of the line. So in this case, we're ignoring that very last quote right here. So this SQL syntax seems to check out. Now let's take a look at the front of this line. We have select link from items where item is equal to, and then we have this %s here. But that's preceded by a quote. So we need to make sure that we end that quote. So the first thing we want to do is put an end quote here. And perhaps we want to pass in some garbage. This is just to help understand why that quote is there. In reality, we probably wouldn't need to do that, but you might want to pass in some garbage so that you can see, hey, we have some text, doesn't really matter what it is, and then we end that quote. We start a new SQL statement using a semicolon, and then we insert our SQL statement here. And so at the end of the day, this is what the actual syntax for this would look like. So that is SQL injection attacks. Now let's take a look at cross-site scripting. All right, so now we're talking about cross-site scripting, and we have this set up here. So what's happening here? We have some sort of a website that lets us send and receive messages from other users, and this page shows all messages sent to you, and the HTML is looking like this. Now, one thing that stands out here is that the actual user, when they're sending this message, the message can include any arbitrary HTML code. And that HTML code will be rendered. Now, this seems pretty crazy, but there is a special functionality protection that says no JavaScript code, so no script tags will be rendered, will be run. So if we include, script tags like this, this JavaScript won't actually be run. So we'll never be able to run any JavaScript, but the goal of this is to effectively craft a message so that Mallory can steal this account verification code. So Mallory wants to get this account verification code from Steam, and she wants to do this without actually running any JavaScript. So for the purposes of this question, we can assume that we have control over these values here, because that is the messages, those are the messages that Mallory sent. And because we have control over these two values, we can think about how can we craft an input that uses the fact that we can control these two values to grab whatever's in the middle and somehow export that to something that we control. So something that becomes really useful here is the image tags. So one thing to note about HTML is that when we start a tag, so say we start an image tag, and then we do something like source equals, and then we have a quote, HTML will keep scanning, all the way until we reach an end quote. And so because we have this sort of functionality where HTML effectively ignores line feeds, ignores spaces, it just treats all of that as one really big string, and it keeps scanning until we have an end quote, we can effectively design an image tag that grabs everything in the middle as an argument to a URL. So maybe this is something like evil.com slash message, or I guess to format this a little bit better, slash message question mark data equals. So this is just saying there's some URL that we control, this evil.com slash message, and we're passing in one argument that is data. And so what we've done is we've started the quote here, but everything beyond that will be contained within this data argument here until we get back to our end quote down here. And so when we have our end quote, then we can just end the tag. And if Mallory sends a message that looks like this in her first one, and she sends a message with that closing quote and the end tag in the second part, this will effectively grab everything in the middle, which is this account verification code, and send that along to this endpoint, this evil.com slash message. We'll send that along as an argument. Now, one thing to note here is that, remember when we actually are using images in these image tags, whatever URL we pass in will be, a GET request will be made to that URL with that actually like validating that an image exists in the endpoint. So even if this is just like a dummy URL that we control and it doesn't actually have an image, the HTML image tag will still make a GET request to that URL. So in this case, that's what effectively lets us exploit the fact that we can use this arbitrary URL to export data in between. So this is a really, clever way of doing this that is very specific to this particular problem. But the big takeaway here is that even if we can't actually run any JavaScript, and there's a lot of modern defenses that don't let us run any, inject the JavaScript on pages, there are still ways to get around that. And these injection attacks that let us get around that, these are very serious problems that we have to pay very close attention to. So this in particular is using the image tag to bypass any prevention that we have against JavaScript. So yeah, that is the problem, and that is it for this walkthrough.